What's the first step in graphing piecewise functions? So if I look at my restricted domains, the number is -2. It's kind of nice when it's the same number, right? Remember, it's not an asymptote. Jenny, what's the next thing?
Graph.
Let's graph it. X plus 5. Jenny, what's my slope in the first equation here? Okay, maybe I'll ask you this question. If I had to graph this, where would I start? Y-axis at what number? So remember, in slope-intercept form, what does the B represent? So our y-intercept is 5. Okay, Jenny, from this point right there, let's darken this. What do I do next? Okay, so you want to use the table of values? We can do that. Tell me some table or numbers that you got for your table of values.
2, 7, 1, 6, 3, 8, 0, 5.
All right, that's enough. So 0, 5, 1, 6, 2, 7, and 3, 8. You'll also notice that your slope here is 1 over 1. A rise of 1, run 1. Does that make sense? Rise 1, up 1, rise 1, up 1. Chen, open or close circle for our orange. How did you know that? Correct. So I'm going to put my finger at -2. She said an open circle, so where it intersects our line. Chen, am I going to go to the left or to the right? Left is correct. Numbers that are smaller are going towards the left. That would be this way. And then I can go back and erase. Raise your hand if yours looks like that. Now, if you're using the table of values, you can even be more wise. It's telling you to pick numbers that are smaller than -2. So in your table of values, you could have picked like -1. Does that make sense? -1. I would graph at that point, so -2, -1. And then you're really just graphing the left of the boundary. Does that make sense? That's another way of thinking about it. Cynthia, how did you graph the blue one? So you factored it? Okay, what did you get? Echo? Cynthia, 3 plus -1 gives me 2, but 3 times -1 is a negative. So can we factor? No. So that one's probably prime. Okay. How do you graph that now? Okay. Can you give me some values that you put in with your calculator? -1. What did you get?
2.
-2.
3. 0 is 3.
That's it? Alright, let's see. -1, 2. Left 1, up 2. Left 2, up 3. 0, 3. So she has her 3 points. If you put in 1, you will get 6. And that means over here it's symmetrical. Everyone say symmetrical. What does that mean? Cynthia looks like found us the vertex. And you see how it's kind of like right one, up one? So left one, up one. So this one is right 2, up 4. This will be left 2, up 4. And my graph would look something like this. Kiana, open or close circle? How did you know that? Equals. Okay. Do I graph to the left or to the right of the boundary? To the right is correct. Now, pay attention, everybody. I'm starting here at this boundary. Ours is closed, so I'm going to fill it in. What did I do? Fill it in. And we go back and erase. Raise your hand if yours looks like that. So, if you don't know how to graph that, use your table of values. And your best friend gets even better. Your calculator can actually graph piecewise functions. Let me show you how to do that. So I'm going to put in the function. I'm going to put it in parentheses. What do you press first? X plus 5. Close the parentheses. And then I'm going to do division. What am I doing? And then another set of parentheses. And I don't have to graph the if part, but I need to get x is less than -2. Less than is a test. Your phone is always testing. What do I mean by that? What happens if you're under 20% with the iPhone? What happens? It warns you that it's in power saving mode, right? There's actually inequalities all over your phone. Did you know that? That's why they call it a logic board. The computer is thinking logically, and we're actually going to use logic. So the button I'm going to press is test. And that's under, right there, underneath alpha, and it's in blue, so I'm going to press test math. Class, what did I press? You know you're there correctly because you have the inequality signs. If you mess up, just press second mode, second quit, and do it again. Second, test when you're in the y equals. And then I'm going to put it less than. -2. Remember, it's not subtracting to, it's negative, and then close the parentheses. If you have a TI-84 plus CE, notice that when we graph it, this one will be in blue and that one will be in red. I should have matched it on my notes. And then I'm going to go ahead and put in this quadratic, so parentheses, x squared plus 2x plus 3. Press division. I need to get x, and then I need to get my inequality. So that would be second math. And then greater than or equal to -2. Whoops. Now, while some of you guys are punching those into your calculator, let's just say, for example, you get a compound inequality. If you get a compound inequality, you have to put in my calculator, I would put in x is less than 1. The word and, x is, pay attention, greater than -1. So if you have a compound inequality like that, you can separate it into two inequalities. The word and is on your calculator when you go to second math and you go under logic and you see the words and or. Okay? So this is what you should have on your calculator. Zoom 6. Oh my goodness, look at that. Look. It gets better. Look. Second graph. Oh, do you guys see what it's doing? It's telling you on your x values for the blue graph for x plus 5. And the reason why it has error on that side is because it says don't go on that side. You're on the wrong side of the boundary. Does that make sense? Wow. You like your calculator, your best friend. You put it to sleep. You clean it. You read a bedtime story. Okay. Almost done. Let's evaluate. 3. X value is 3. Put your finger on orange or blue. Oh, I'm supposed to write x. Your x value is 3, so x, is it less than negative 2? No. Is x greater than negative 2? And so what you would do is you would just put in 3 in there, or I can just use my calculator. And the answer is 18. Raise your hand if you got that. So I'm kind of showing you both ways. Algebraically, table of values, and then you can't do that on my graph because we didn't graph high enough. Does that make sense? I would just look for the intersection. Negative 4 goes in this one, so negative 4 plus 5, that would give us 1. And then negative 2. Negative 2 is not here because it's not smaller than negative 2. It's equals 2, so you put it in there, and you get an answer of 3. Piecewise function, 2 pieces with quadratic and a linear. And then we also evaluated the piecewise function.